Welcome, everyone. Thank you for joining us for today's webinar, Essentials of Fall Protection Programs. My name is Dave Galbraith. I'm the Assistant Vice President of Risk Management, Technical Lead at Amerisure Insurance, and I'll be your moderator for this afternoon. As many of you know, Amerisure is one of the nation's leading providers of commercial insurance. We specialize in managing risk for businesses in construction, manufacturing, and healthcare. We're licensed to do business in all 50 states and have been in business for over 100 years. There are currently over 750 Amerisure employees, with our headquarters located in Farmington Hills, Michigan, and 12 strategically located core service centers around the country. We have to do a little housekeeping before we get started. If you have any questions during the presentation, please type them in the question box in your GoToWebinar control panel. I'll bring them up during the presentation, and we will have time at the end to answer all the questions. Due to the number of attendees and to avoid background interference, all attendees are muted and will remain muted for the duration of the webinar. Before we begin, I'd like to clarify that this webinar is for general information only and not intended to provide and should not be relied upon for legal advice in any particular circumstance or fact situation. You are advised to consult with an attorney to address any particular circumstance or fact situation. Amerisure assumes no duty or obligation to any party in providing this information. This material is for informational purposes only and is not intended to provide specific solutions for any potentially unsafe conditions. With that out of the way, our presenters today are Terry Haltman and Marcus Raspberry. Terry is based in our Dallas Core Service Center and has been a part of the Amerisure Risk Management team since 1995. He graduated from Oklahoma State University with a Bachelor's of Science degree in Mechanical Engineering Technology and is a certified safety professional. Marcus is based in our Tampa Core Service Center and has been with Amerisure since 2016. He is currently pursuing his ARM and ASP professional designations and is a member of the American Society of Safety Engineers. He was also recently named Safety Professional of the Year by the American Society of Safety Professionals Central Florida chapter. Both Terry and Marcus have a wealth of knowledge to share, so without further ado, I will turn the time over to our experts.
Thank you, Dave. We appreciate the introduction. It's great to be speaking with all of you. We are pleased to offer this webinar as part of Amerisure's 2019 Fall Prevention and Safety Campaign. We'll start by discussing some statistics around falls on construction job sites. Then we will go over OSHAS expectations when it comes to fall protection, job site controls, employee training, as well as rescue strategies should a fall occur. We'll wrap up the webinar with a question and answer session, so be sure to type your questions in the GoToWebinar control panel as they come up during the webinar. If we have a lot of information to cover, so let's go ahead and get started. Falls continue to be the leading cause of death in construction. Of the 971 construction fatalities in 2017, 366 were fatal falls to a lower level. Even on same level surfaces, slips, trips, and falls make up 15% of all accidental deaths. While the construction industry reports the highest number of falls annually, falls also make up the majority of general industry accidents, as these accidents continue to be the most frequently reported injuries, totaling 25% of reported claims per year. We feel a responsibility to share prevention and safety tips that may benefit partner agencies and policyholders. Fortunately, the majority of falls can be prevented. By sharing tools and resources with you today, we are hoping to raise awareness and increase safety culture, so we can see a decrease in the shocking statistics shared on the previous slide. It is the responsibility of the employer to provide protection for employees, and Amerisure's risk management team is here to help you do just that. All workers have a right to return home safely to their families every day. So employers must provide workers a place of employment free from recognized hazards. That means it's the responsibility of the employer to provide adequate fall protection. OSHA's Subpart M details the requirements of fall protection in construction workplaces. It applies when employees are working at heights 6 feet or more above a lower level. It also outlines protection from falling objects, falls from tripping over or falling through holes, and protection when walking and working around dangerous equipment without any regard to height. It's no surprise that it's the responsibility of the employer to provide adequate fall protection. I want to briefly touch on some of the specifics of OSHA's expectations, most of which we will cover in more detail later in this presentation. To prevent employees from being injured from falls, employers must provide a guardrail and tow board around every elevated, open-sided platform, floor, or runway. Guard every floor hole that a worker could accidentally walk into, and when necessary on the job site, provide personal fall arrest systems, safety nets, stair railings, and/or handrails. OSHA also requires employers to provide working conditions that are free of known dangers, keep floors and work areas in clean and dry condition, select and provide required personal protective equipment at no cost to workers, and train workers about job hazards in a language that they can understand. Generally, fall protection can be provided through the use of guardrail systems, safety net systems, or personal fall arrest systems. OSHA refers to these as conventional fall protection systems. On this slide, the graphic on the left is a visual representation of a safe job site, and the graphic on the right displays an abundance of unsafe, hazardous conditions. On subsequent slides, we will discuss the various job site controls seen within the graphic on the left, such as guardrails, tow boards, personal fall arrest systems, and more. Feel free to take a moment to examine these graphics before we move on. The first fall protection system we'll discuss today is a personal fall arrest system, which is an anchored body harness that will allow a worker to fall, but prevents the worker from hitting the ground, equipment, or other hazards below the work area. This system is comprised of an anchorage, body support, and connecting means. The anchorage is the secure means of attachment to which a personal fall arrest system is connected. The anchorage point must be capable of supporting 5,000 pounds, so a guardrail cannot be used as an anchorage point. Proper installation of the anchorage point is critical to the success of this system. It must be designed and installed to support the amount of force that would be applied to it if a worker fell. Consulting the manufacturer's instructions or a registered professional engineer will ensure this critical component is properly installed and maintained. The body support really means a body harness, and there are two types, a full body harness and a waist belt. Waist belts cannot be used for fall arrest, but can be used for fall restraint and work positioning. Workers must be trained in the proper wear and use of the body harness. They are not a one-size-fits-all component. Proper sizing is critical to preventing injuries. The harness must fit snugly across the chest and around the thighs, and the D-ring must be positioned in the center of the back between the shoulder blades. It is the responsibility of the employer to ensure workers use a size that fits properly. The connecting means provides a link between the anchorage point and body support. This can include an energy-absorbing lanyard, anchor strap, carabiner, double-locking snap hook, or other devices. These devices must meet the required strength criteria. Once a personal fall arrest system arrests a fall, it must be taken out of service. According to OSHA, these systems and components subjected to an impact loading must be immediately removed from service and shall not be used again for employee protection until inspected and determined by a competent person to be undamaged and suitable for reuse. However, while OSHA states it can be used again if a competent person deems so, our advice is that it should not be used again for fall protection. Rescue should automatically be considered as part of the fall arrest protection because if the worker is protected from severe injury as a result of the fall, but is injured or dies waiting to be rescued, the system has failed. We will discuss rescue strategies more in depth later on in this webinar. The next fall protection system we'll discuss today is a guardrail, which is a barricade system that prevents employees from falling through a hole or off an edge of a lower level. Always be sure to consult the manufacturer's instructions or a registered professional engineer to ensure proper guardrail installation. Once properly installed, guardrails are sometimes referred to as a passive fall protection. That means it requires no action by the worker to be safe, as long as the system is properly maintained. The requirements for guardrails are clearly stated in OSHA regulations. They must withstand 200 pounds of pressure in any direction, and they must have a top rail and a mid rail. As you can see on the screen, the top rail must be 42 inches plus or minus 3 inches above the working level. A mid rail must be installed unless there is a wall or a parapet at least 21 inches high. The mid rail must be halfway between the top rail and the working surface and needs to be able to withstand 150 pounds of force. All rails need to be at least a 1/4 inch in diameter. Toe boards, otherwise known as low protective barriers, must be used for protection from falling objects and need to be a minimum of 3.5 inches tall. Some additional items to keep in mind when considering the use of guardrails: steel banding or plastic banding cannot be used as top rails or mid rails. When employees are using stilts or working on elevated platforms such as Baker's scaffolding, the top rail must be increased an equal amount to the stilt height or the elevated platform. The third fall protection system we will discuss is a safety net, which also falls under that passive system umbrella, because when they are properly installed and maintained, the workers do not have to do anything with the system to be safe. A safety net system is a mesh net that catches and supports the weight of a falling worker. Installation, adjustments, and maintenance of the netting should only be made by properly trained personnel. When safety nets are used, they must be positioned as close as practical under the surface on which the employees are working. This means no more than 30 feet below. They must also be installed with sufficient clearance under them to prevent contact with the surface or structures below. These nets must be drop tested or certified, and you should always give consideration to the potential impact load on the net and lateral load on those stud walls in the event of a fall. On this screen, you'll see an example of a warning line system. These systems can be used only on low slope roofs. They consist of a barrier to warn workers of an unprotected roof side or edge and designate an area where roof work may take place without guardrails, personal fall arrest systems, or safety nets. The black line around the perimeter of the graphic indicates the roof edge, and the red dashed line represents the warning line. Only employees performing roofing work are allowed between the warning line and the roof edge. The warning line must be erected around all sides of the roof work area, should be no closer than 6 feet from the roof edge, and should be flagged at no more than 6-foot intervals. The green arrow on the screen points to the access path, which is formed by 2 warning lines and connects the work area to the materials handling areas, storage areas, and hoisting areas. When the access path is not in use, it should be barricaded by rope, wire, or chain of equal strength at the same height as the warning line system. A controlled access zone may be used for overhand bricklaying and related work, or as part of a fall protection plan where it is infeasible or creates a greater hazard to use conventional fall protection equipment. The controlled access zone should be defined by control lines or other means that restrict access. The control lines must be no less than 6 feet and no more than 25 feet from the unprotected or leading edge, except when erecting precast concrete members. The control line should extend along the entire length of the unprotected or leading edge and should be approximately parallel. On floors where guardrails are not in place, the controlled access zone must cover all points of access, materials handling, and storage areas. On floors and roofs where guardrail systems are in place but need to be removed to allow overhand bricklaying or leading edge work, only that portion of the guardrail necessary to accomplish that day's work should be removed. Now that we've covered the OSHA's expectations and various fall protection systems, I'm going to now turn it over to Marcus Raspberry.
Thank you, Terry. I'm going to discuss some hazards associated with fall arrest systems and what you can do to prevent injury from occurring. When putting together a fall arrest system, it is critical to calculate the amount of clearance needed for workers. The typical components you need to include when calculating free fall distance are lanyard length, deceleration distance, worker height, and safety factor. Then you have the total distance from the anchor point. A provision for fall clearance in itself does not guarantee that a fall will not result in impact with the structure unless provision is made to ensure that a swing fall does not result in impact with an object to the side of the fall line. An impact from a swing fall can be just as serious as an impact with the ground. Swing falls are a particular hazard with retracting cable lifelines because the length of line that is available allows a major swing fall even if the vertical component of the fall is arrested immediately. To limit swing falls, it is important to use anchors as far as possible directly above the work area. If substantial horizontal movement is required, a horizontal lifeline is the best solution. However, bear in mind that this gives freedom to movement in only one orientation. Excessive movement at right angles to the lifeline may result in a dangerous swing fall. Another solution is to use 2 lanyards connected to anchors at different positions. In the case of the self-retracting lifeline, it may be possible to use a lanyard connected to a nearby anchorage to counter the swing, or even a rope and rope grab tied to an anchorage opposite the anchorage for the lifeline. As the least preferred solution, the anchorage for the lifeline might be raised a few feet in order to reduce the angle of the swing. Generally, the use of 2 anchorages is necessary to eliminate swing falls. Depending on the work site, it may be possible to use a separate restraint line or otherwise an ankle rope fitted with a rope grab to allow movement in conjunction with the main fall arrest system. This slide explains the process of suspension trauma leading to death, which research indicates is possible in less than 30 minutes. Following the fall, a worker may remain suspended in a harness. The sustained immobility may lead to a state of unconsciousness. Depending on the length of time the suspended worker is unconscious or immobile and the level of venous pooling, the resulting orthostatic intolerance may lead to death. While not common, such fatalities often are referred to as harness-induced pathology or suspension trauma. Orthostatic tolerance may be defined as development of symptoms such as lightheadedness, palpitations, poor concentration, fatigue, nausea, dizziness, headaches, sweating, weakness, and occasionally fainting during upright standing. While in a sedentary position, blood can accumulate in the veins, which is commonly called venous pooling, and cause orthostatic intolerance. Orthostatic intolerance also can occur when an individual moves suddenly after being sedentary for a long time. For an example, a person may exercise orthostatic intolerance when they stand up quickly after sitting for a long time. As you can see on the screen, the process of suspension trauma leading to death is as follows. Fall arrested by harness, blood pools in leg muscles and brain oxygen levels fall. Brain raises pulse rate and respiration to compensate. More blood pools in legs and blood flow to the brain reduces. Syncopal response triggered by pulse and breathing rates drop. Losses in consciousness but remains upright. Brain oxygen levels continue to fall and posture places airways at risk. Brain damage and eventual death. To rescue a worker at risk of suspension trauma, OSHA recommends the following general practices and considerations. Rescue suspended workers as quickly as possible. Be aware that suspended workers are at risk for orthostatic intolerance and suspension trauma. Be aware of signs and symptoms of orthostatic intolerance. Be aware that orthostatic intolerance is potentially life-threatening. Suspended workers with head injuries or who are unconscious are particularly at risk. Be aware of factors that can increase the risk of suspension trauma. Now that we know the dangers of suspension trauma, let's take a look at the differences in how suspension trauma would occur depending on if the worker was wearing a safety belt as opposed to a full body harness. These graphics visually explain why a safety belt is more hazardous than a harness, both for fall arrest and its impact on suspension trauma. The one on the left is an old safety belt which is no longer permitted to be used based upon the design. A person could slip through it if they fell head first. Also, the belt could turn and the lanyard D-ring could be in front, which would cause severe injury to the back when the fall stops. Body belts have not been allowed as a part of the arrest system since 1998, as they can cause internal injury more severe than a fall. The graphics in the middle and on the right show the use of a full body harness, which is designed to minimize the impact on the body during the fall by distributing the force of the fall over the entire torso. The graphics show when the pressure points occur when the worker is suspended, with the majority of the weight occurring with the leg strap. This would restrict the blood flow, which over an extended period of time could also cause suspension trauma. Before we get into the specifics, I wanted to provide an overview of the steps that should be taken when it comes to using fall protection equipment. You should understand all federal, state, and local regulations pertaining to fall protection before selecting and using fall protection equipment. You also need to read all instructions and warnings contained on the product and packaging before using the equipment. And all fall protection equipment should be inspected prior to each use. Training is very important. All workers should be trained by a competent person in the proper use of fall protection equipment. When it comes to system components, only components that are fully compatible with one another should be used. Fall arrest systems are designed and tested as complete systems and should be used in this way. Lastly, what do you do after a fall? If a fall occurs, all components of the fall arrest system should be removed from service. OSHA states that an impacted fall arrest system or its components can be used again if a competent person deems so. However, our advice is that it should not be used again for fall protection. If involved in a fall protection incident, it may also be wise to take it out of service and store it in a secure place in case of potential litigation. Employees should be trained in proper equipment selection, inspection, and maintenance. Train employees to select a harness and lanyard that will meet the weight capacity of the individual and tools combined. The harness must fit the individual comfortably. The weight capacity of the lanyard must meet or exceed the weight capacity of the harness. Select a harness and lanyard that will withstand the environment that it will be exposed to. For example, there are harnesses and lanyards that are made specifically for use where welding or cutting of metal will be performed. Every fall protection system should be checked regularly to make sure it's effective. All parts should be in working order, and if they are not, the area should be considered unworkable until a new system is put in place. When inspecting the harness of your personal fall arrest system equipment, first, you should check that there are no cuts deeper than 1/16 of an inch. If such a cut exists, you should dispose of the harness. There is a colored thread of 1/16 of an inch in each harness. If you can see the red thread, throw it out. Check that the tags and labels are attached and fully legible. Pull on the areas where there is stitching. If more than 2 stitches and the stitch pattern breaks or is broken, dispose of the harness. There may be a dry rot. Welders should check their harness, make sure that their harnesses contain Kevlar. It is 2.5 times the cost, but it will last 10 times as long. To check for dry rot, run your hand along the webbing. If you feel hard spots that may be dry rot, lastly check for bluing, which is bluish tinge in the metal due to exposure to intense heat, or grommet holes. And if someone has punched additional holes in the tongue, the harness is probably not properly matched to the employee. When inspecting the lanyard hardware, check for hook eye distortions, cracks, corrosion, and pitting. Ensure that the keeper latch seats without binding. There should be no distortions or obstructions. Lastly, check the keeper spring force and keeper locks operations. To clean the personal fall arrest system, use a mild detergent and let it hang dry. When dry, store the harness and lanyard in an area that will prevent damage while not in use. Be sure to keep it away from excessive heat, and keep in mind, you should never pressure wash a harness, as the pressure may damage the fibers or stitching. One of the best ways to improve safety culture is to learn from the gaps and opportunities in other programs. So we're going to share a policyholder scenario with you. An experienced Mason who had been with the organization for several years and was known by the supervisors as a good, dependable employee fell approximately 10 to 12 feet from the second level of a tubular scaffolding through an opening in the scaffold handrail. The employee struck his head, resulting in severe closed head injury. No explanation was given as to why the handrail was removed or why the employee was not appropriately tied off. By all appearances, the appropriate controls were in place. A formal written safety program was in place. Job site safety meetings were conducted weekly. A competent person was present on every job site, and management commitment was evaluated as either average or above average in all areas. And the safety program and its ability to control exposures were evaluated as excellent. So what lesson was learned? Safety programs and policies are only as strong as their weakest link. Any safety program is only as effective as the employees who make choices to follow the policies and procedures, and their supervisors who choose to enforce or ignore them. If while on the job site, anyone observes an act or a condition that is unsafe and no one proactively corrects the situation, employee or management, the program is not effective. Additionally, job site observations are critical. If anyone observes an unsafe act or condition, it most likely is not the first time it has occurred. On job sites, every associate, along with the contractor, should be held accountable. If uninterrupted, it is very likely that a fatality will eventually occur. Over the course of 2019, employees from Amerisure Risk Management, corporate underwriting, and marketing teams are collaborating to provide our agencies and policyholders timely resources and information regarding fall prevention and safety. Similar to our 2018 Distracted Driving campaign, we are utilizing email, social media, and Amerisure.com to communicate messages on a monthly basis. The campaign focuses on fall from height for the first half of the year, and starting next month, materials will revolve around slip, trips, and falls. If you haven't already, we encourage you to head over to Amerisure.com to check out all of our fall prevention materials we've posted, including a ladder safety video. The true success of our campaign is dependent upon the participation of our partner agencies and policyholders. We'll hope you'll join us in committing to making a difference to reduce fall-related accidents in and at your workplace or in the community. We've covered a lot so far, so in conclusion, I would try to summarize some of the takeaways. All workers have a right to return safely home to their families every day. We cannot let workers get injured when effective means are readily available to prevent those injuries. There have been considerable advances in the types and capability of commercially available fall protection equipment, including guardrails, safety nets, and personal fall arrest systems. It is very important to note that every fall protection system should be checked regularly to make sure it's effective. All parts should be in working order, and if they are not, the area should be considered unworkable until a new system is put in place. Additionally, workers should be trained in proper equipment selection, inspection, and maintenance. As a reminder, your Amerisure risk management consultant is always available to assist in developing the fall protection program for your workplace. Thank you for joining us, and we hope you found the information to be informative and valuable. We're now going to be accepting any questions you may have before wrapping up today's webinar.
Thank you for your insightful discussion, Marcus and Terry. We'll go ahead and take some time for questions now. Just a reminder, please be sure to type your questions into the question box in your control panel. We'll wait a minute or two to see if any questions come through, and if not, then we'll close up the webinar. Thank you. Looks like we don't have any questions today, so I'd like to thank everyone for attending. Terry and Marcus, is there anything else you wanted to cover before we wrap up?
None for me.
Thank you, everyone. We appreciate you being here and hope you learned a lot about the dangers of falls in construction and what you can do to protect your employees. We will be sending out all webinar attendees the presentation from today, so please keep an eye out in your email for that. We will also send the link to the Fall Prevention and Safety Campaign page on Amerisure.com for your convenience. Thanks again for joining us today, and we hope to see you again for our next webinar in September. Thank you and have a safe day.